But we do want our answer as a mixed number. But the first thing we do want on this problem is to change the mixed numbers into improper fractions using, once again, cycle method. Now I'm going to set up my two fractions right now, so don't forget. And the cycle method, right? So 7 times 2 plus 1. Let's do that. 7 times 2, that's 14. Add the one numerator to make that 15. So that numerator is 15 there. And the denominator stays the same. It's still 2 denominator from this. Then we go to the 5 3/4. So cycle method, 5 times 4 plus 3. Let's go ahead and show that right there. 5 times 4 is 20. Plus the 3 numerator, that's 23. So that's my new numerator there for that second fraction, 20, not 23. And the denominator stays the same, it's just a 4. Okay. Now, like I said there at the beginning, is we should be looking at this, and we should see right here, excuse me, that 4 is a multiple of 2. Now, what this means, at least for me, is that I shouldn't need to change that second fraction. I only need to change the way that first fraction looks. Again, we're not changing its value, just the way that it looks. And I would just say, well, since 4 is a multiple of 2, what would I have to scale that denominator of 2 by to make it 4? Now, of course, if you use the previous methods that we've been using, like I'm going to take 2 times 4 and 4 times 2, it will still generate common denominators, okay? But I'm just going to show you that just with a little bit of analysis, at least if we see common multiples like this, it can sometimes simplify things for us. So I would know that this first fraction, if I can change that 2 into a 4, then I will have common denominators. Well, that means I'd have to multiply by 2 here. And we see and we know that 2 times 2 is, well, 4. Now, before we look at the second fraction now, I'm going to scale the numerator by 2, so that's 15 times 2. 2 times 5 is 10, carry the 1. 2 times 1 is 2, but add the 1 makes that 3. So I have 30 fourths. Now, let's say that you did 2 times 4 and 15 times 4. You would have just had, let's see, that'd be 68, right? Okay, so if you got that while working this problem, then you'd see that you'd still be on the right track. Okay, now, the way that I'm doing it, though, just a little bit different. I can keep the second fraction the same as 23 fourths. And yes, the denominators match now, which is exactly what I want, which allows me just to, I guess not have to scale that second fraction. Perhaps that's more convenient, perhaps it's not. It's up to you to decide. But I'm going to take my two numerators now and add them together, keeping the denominator the same as 4, and this will give me some number in fourths. Let's go and add those two numerators. 30 plus 23. So 0 plus 3 is 3, 3 plus 2 is 5. So that's a new numerator of 53 fourths. Now I would look at this. If you had done this in eighths, the second fraction would have been 46 eighths, and if you had added those together, you would have had 106 106 eighths, which then would have simplified to 53 fourths. Now this one just happens to not simplify the way that I have it, which is again just there's some convenience there. But I would look at 53 and 4, right? I mean 4 is divisible by 2, but 53 is not. So there we go. We see this improper fraction, and it is not simplifiable at this point. So I'm going to change this improper fraction into a mixed number by taking 53 and dividing it by 4. And we should have our 4 multiplication table down. So 4 goes into 5 once. 1 times 4 is 4. Subtract. Here's a 1. Drop the 3. 4 goes into 13 3 times. 3 times 4 is 12. When I subtract that out, I get 1, and that would be my remainder. So our quotient 13, that's our whole value in the mixed number. The denominator is unchanged. It's still 4. Our remainder is 1. And yes, I see here the 1/4 cannot be simplified. And so our final answer is 13 and 1/4. What I've shown on all these problems is, it's essentially one strategy for solving these. There's another one, And that's just to work with the mixed numbers directly. Now, I'm not showing that method because it would be kind of a new strategy which tends to cause more confusion than it does help students. So I'm not showing it. Now, later on, perhaps in 950 or 980, you will see it and you would understand it better because you'll have a little bit more experience with this stuff under your belt. And if you know what I'm talking about, you're welcome to use that strategy. Just use it with caution because from time to time, students are just more likely to make more mistakes in that method than to use this method, okay? Especially while we're doing all the calculations by hand. So cycle method, scale your denominators or force the denominators to be the same, perform your operation, and then that'll give you your improper fraction. You just need to change it to a mixed number, that's all.